So in section 5, what this video is going to cover is going over the ambiguous case. And so that's if we're given a side, and then an angle that's not in between them. And this case is called the ambiguous case because there are three different things that can happen. And so we sketched this in class. We drew some line segment Y. We didn't know how long it was. We sketched a 26-degree angle. That's angle X. Side Z was set at 8 centimeters. And then we went through and did three different cases. So the first one is we said that the second side was 5 centimeters. So we had side, angle. Well, if X was 5 centimeters, we could either swing it in or we could swing it out, and we could create two different triangles from this one set of information. And so again, we could have two possible triangles when X was 5 centimeters. We then kept angle X being 26 degrees, side C being 8 centimeters, and then we looked at what would happen if X was 9 centimeters. And so we sketched another triangle, and if we tried to swing it in the other way, this side length was longer than this side length, and so it would end up having to come somewhere over here, which would then change this 26-degree angle. So there was only one possible triangle when X was 9 centimeters. The third case that we looked at is if X was 3 centimeters, Z stayed as 8, angle X stayed as 26, so again, side, angle. And when X was 3 centimeters, it didn't reach. And so there were no possible triangles when X was 3 centimeters. And so these are the three different things that can happen depending on your set of information, but all of these come from the side angle case. One thing that you could do is figure out, well, what would the shortest side possible be? And so the way that you would get this smallest length is by just drawing it straight down. And so you could think of this as a right triangle. So we could figure out what the smallest value of X would need to be if this was a 26-degree angle and then this was 8 centimeters. So from here you could use the sine of 26 degrees is equal to X over 8. So X will equal 8 times the sine of 26, which we could then figure out pretty quickly in our calculators. And the smallest value that X could ever be to create a triangle with this information is 3.507 centimeters. Well, that's then obvious why 3 centimeters didn't create a triangle with this given information for side Z and angle X. Now notice that side Y is variable depending on what the side length for angle X is. And also if you look right here, this triangle, side Y would be this distance, so fairly small. But if we swing this 5 centimeters out the other way, Y would be this distance, so a little bit bigger. Here are the two possible lengths for length Y if X was 5. If X was 9, Y would be this distance here. And so to find that angle Y, we're going to use the law of cosines, and so you can find that on the next video.